So, hello everyone. We are going to discuss a very important topic in medicinal organic chemistry, and that is sulfur drugs. We'll be just taking two aspects, that is, synthesis of different sulfur drugs and the uses of those sulfur drugs. So, if we say that we are discussing sulfur drugs, the molecules that we consider over here must at least have sulfur group in different formats, and our focus will be mainly on derivatives that have a SO2 group or sometimes even sulfonamide group. That is, you have a NH group attached somewhere like this. So, first of all, we should be very clear that in this topic of sulfur drugs that we are going to study, the sulfur content has to be there in different formats, and one of those formats is sulfonamides. There are few selected sulfur drugs that are to be discussed, of which the first sulfur drug that we are going to discuss today in this lecture is sulfonylamide. Whenever we say that we are discussing sulfonylamide, we must be very clear that in this process of sulfonylamide, there are three different methods available for its synthesis. And in few selected drug synthesis, when you have more than one possibility, it is favorable that we should discuss all. The sulfonylamide drug can be prepared by three different methods, of which one is preparing sulfonylamide from benzene. The second is preparing sulfonylamide from sulfonylic acid. And the third method is preparing it from acetanilide. So over here you have three different methods by which we can prepare sulfonylamide, one of the sulfa or sulfonamide derivatized sulfur drugs. So let us start with its synthesis by the first method. And when we say the first method, be very clear that we will be starting with the method that involves benzene as the starting material. As we all know that benzene in presence of concentrated HNO3 and concentrated H2SO4 always helps us in getting a nitrating reagent, that is NO2 plus. The change that will occur over here would be the hydrogen on one of the carbon of the benzene will be replaced by the NO2 group, and simply you will get nitrobenzene. So this will be the first step that is involved in the synthesis of sulfonylamide. Once the nitrobenzene is obtained, this nitrobenzene undergoes a very popular reduction reaction using SN and HCl. And remember very well, whenever we say SN and HCl, a reaction takes place where SnCl2 is obtained and dihydrogen gas is made free. Imagine that this reaction is repeated thrice. When it is repeated thrice, you get 3 moles of H2, and these 3 moles of H2 are utilized in conversion of nitrobenzene to its reduced product. And we all know that the reduced product of nitrobenzene is aniline. So the 2 oxygen and 4 hydrogen from this cluster will very easily get converted into water molecules, that is 2H2O, and 1 mole of H2 will be joining at this place. So you have simply undertaken the nitration reaction followed by the reduction reaction using a popular reducing agent, that is tin plus HCl. Now let us check the further steps that are involved in the synthesis of sulfonylamide. Once we are done with the synthesis of aniline, we must undergo a reaction where sulfonation takes place. So over here, if we undergo a sulfonation reaction using sulfuric acid and heating at the para position where the steric hindrance is minimum, remember very well the words I am saying, at the para position where the steric hindrance is minimum, a SO3H group is formed over here. So it is NH2 and SO3H. We popularly call it as para-aminobenzene sulfonic acid. Para-aminobenzene sulfonic acid. Now, I am writing an equivalent structure to this. Why we require an equivalent structure to this? You will come to know once we move ahead of this step. So it is same. Over here I am writing SO2 and OH. It is no change. SO3H and SO2 and OH are one and the same. There is no change. But I wanted a OH present over here to be replaced by some group, and to mention that specifically I have made the SO3H to be rewritten as SO2H. Now at this particular point, if we undergo a PCl5 reaction, then the OH from here will be replaced by a Cl, that is a chlorine group, and we will end up writing NH2 and SO2Cl. And this particular reaction where the OH is replaced by Cl undergo ammonolysis, that is either in presence of pure ammonia or ammonia that is diluted in water or dissolved in water, that is NH4OH. But that NH4OH has to be concentrated. In such a case, if you will check properly, a molecule of HCl will be removed and we will end up with a popular product, or rather to say a desired product, sulfonylamide. So friends, this is how we are getting our first product, sulfonylamide, by its first method. So over here we have explained the, or rather we have discussed the synthesis of sulfonylamide from benzene. Let us move ahead and discuss the second method of the synthesis of sulfonylamide. As it was benzene from which sulfonylamide was obtained, we even have sulfonylic acid from where sulfonylamide can be obtained. In such a case, the first step is to undergo acetylation. And when we say that we are undergoing acetylation, the popular reagent is CH3CO twice O, that is acetic anhydride, and sometimes a sodium acetate is used as a catalyst or in a catalytic amount to facilitate such reaction. We should also know the structure of acetic anhydride because it will help us understand the role of this reagent and its reactivity. This will break from this particular point. A hydrogen from here and this large group will be converted into CH3COOH, and this particular group will attach over here, and therefore you will get SO3H and NHCOCH3. So this will be your first step that you are getting. Now this particular product undergoes the reaction with ClSO3H, that is chlorosulfonic acid. This chlorosulfonic acid can also be written like this, because the reason of writing the chlorosulfonic acid in this format is also very important. When we write chlorosulfonic acid in this format, we would be able to replace few groups that are present on a particular point. And undertaking such a reaction, we will very easily be able to replace this position, or rather to say a OH over there, by a Cl, because you will have SO3H, which can also be written as SO2OH, which we have learned just now. So this will be converted into SO2Cl, and at the bottom you will have NHCOCH3. So this is a simple conversion that took place, and this is now para-acid amidobenzene chloride. Sometimes it is written as ASC, and this particular molecule, that is para-acid amidobenzene chloride, is then reacted further with ammonia, or rather to say we undergo ammonolysis. When we undergo ammonolysis, this chlorine and this hydrogen from here will be written as HCl. So we will be getting over here SO2 NH2, sorry for that, and on this side you will have NHCO CH3. This particular part, which is not much visible, is SO2 NH2. So the last step that is involved over here is a acidic hydrolysis, and when it undergoes the acidic hydrolysis, this part is again removed, and hence we are able to get our desired product, that is sulfonylamide, using the method number 2. So in all, up to now, sulfonylamide is synthesized by two different methods. The second method was starting from sulfonylic acid, and the first method was initiating from benzene. Now let us move for the third method, by which we can again prepare, or rather synthesize, our desired product, that is sulfonylamide. So again, while moving with the third method or a different method, we should be aware that this is the product what we are going to synthesize, or we are interested in. So synthesizing sulfonylamide, let us start it from acetanilide. So starting it from acetanilide, it is NHCOCH3. So acetanilide simply undergoes a reaction with chlorosulfonic acid. When it undergoes the reaction with chlorosulfonic acid, at this particular point you have a hydrogen. This chlorosulfonic acid can again be demonstrated as this. So the OH and H is removed as H2O, and at this particular point you will be able to write NHCOCH3 and SO2Cl. So this is your step 1. Now as you have this SO2Cl, you undergo ammonolysis reaction by writing ammonium hydroxide in a concentrated format around 40 to 85 degrees centigrade, and this will help you convert this Cl into NH2 group, and therefore at this set of the reaction you will have SO2 NH2. So now you are very much aware about the last and the popular step, that is acidic hydrolysis. And undertaking acidic hydrolysis, this part will be removed as a byproduct, and over here you will have your final product available, which can be written as SO2 NH2 and NH2. So friends, these are the method, or these are rather the way of synthesizing sulfonylamide drugs, or three different procedure by which sulfonylamide drug can be obtained. Now be very clear that it is used as an antibacterial agent, or sometimes it can be replaced through some of the older drugs. But our main aim in this discussion or in this video will be synthesis. So let us focus on such type of synthesis. So this is our first synthesis that we have undertaken, and it is the synthesis of sulfonylamide. If we just go back and recall the steps, the third method was from acetanilide, the second method was from sulfonylic acid, and the first method of synthesis is from benzene. So this is the first product that we have synthesized up to now, which belongs to the class of sulfonamide, and it is in the category of sulfur drugs. Now let us move towards the second, and that is sulfathiazole. Whenever we say sulfathiazole, remember very well, this sulfathiazole is nothing but combination of sulfonylamide and a thiazole ring. What is this thiazole ring? So it is a ring where you have both nitrogen and sulfur present. So such type of ring would be required in the synthesis of this sulfathiazole. So as a part of our step 1, let us first synthesize sulfathiazole, thiazole in some different way. So first step will be to prepare 2-amino thiazole. So what is the method to prepare 2-amino thiazole? You have thiourea, that is NH2CS NH2. It will be reacting with 1,2-dichloroethyl acetate. So 1,2-dichloroethyl acetate, you have a very important reagent over here. So first of all, let us check what we have written. So it is ethyl acetate. So is that particularly clear that what we have written? Let us check. You have CH3, COO, C2H5. This is ethyl, this is acetate. This C2H5 is nothing but CH2, CH3, and one H was replaced by one chlorine. Second H is replaced by second chlorine, so you will have CH2. So yes, we are correct. We are writing a correct structure. Now, when these two reagents undergo a cyclization, or rather to say a condensation reaction, you will find that minimum of 2 moles of HCl is coming out with other desired byproducts, but you will end up writing a molecule like this, and in this particular molecule that we are writing or we are mentioning, you will find H2 group. So this product that we have mentioned is 2-amino thiazole. Excuse me. So 2-amino thiazole is our step 1. This 2-amino thiazole will be reacted further, and friends, do not forget to mention here thiourea. Now the 2-amino thiazole that is obtained is further reacted. Let us check how. So the product obtained from step 1 is 2-amino thiazole. This 2-amino thiazole will be further reacted to get our second step or the second desired product. What is that? So in the step 2, we are in requirement of a product that is NH2 SO2Cl. How is this product possible, or how is this product available? It is very easy to obtain. There is no difficulty in obtaining this product. So I will write this product once, the method to obtain this product, and then we will continue every time whenever required in the same method that I will not mention. Over here, if I say we will start with nitrobenzene, if I undergo a reduction with tin and HCl, this nitrobenzene will be converted into aniline. This aniline on further reaction with chlorosulfonic acid, it is very clear that H from here and OH from here will be removed as H2O, and at this particular junction you will end up writing SO2Cl. If such is the case, you can directly get this product. Sometimes what happens, there is a doubt at this particular point that the reagent that is coming out of it is SO2Cl. Will it directly go and attack to the para position, or it might also come to the ortho position? So to restrict the ortho position, what we do from this particular point is we first undergo acetylation. I have taught you just now that if we undergo acetylation, acetic acid is removed, we end up with acetanilide. Once we end up with acetanilide, then we undergo chlorosulfonic acid. And at this particular point, it is rewritten as SO2Cl. And now, if we undergo acidic or basic hydrolysis, this part will be removed, and now we will be able to write this as a product. So you can see the desired product is obtained in two different ways: a very simple method, a direct method, and a product. But sometimes if the question of the orthopara attack comes, step 1, step 2, step 3, and step 4. This is one method, and step 1, step 2, this is another method. But according to me, the more desirable method will be this long method. The more desirable method will be this long method. So now, as we are having both the reagents available with us, we will just combine the two under a condensation reaction. One is this product, and the second one is, the second one is this product. So let us check what happens when these two products are combined. Combining these two products, we will be able to get the titled drug, that is sulfa thiazole, SO2Cl, reacting with. Now here we have to be very careful. Why? I will be flipping this. Once I flip this, what happens is very important. Let us check. Once I flip this, N will remain there, but S will change. So this is to be taken very cautiously, whatever we are writing. And over here it will be NH2. So now friends, it's very clear at this point that Cl and hydrogen from here undergoing a condensation reaction will be removed, and we will be getting our final desired drug or molecule, that is sulfathiazole. Again, so this is how we will be getting sulfathiazole. So this is our second important product that we were interested in, and it is obtained as sulfathiazole. So friends, we have just completed two different syntheses. One is the sulfonylamide synthesis, and the second one is the sulfathiazole synthesis. Let us move ahead with our third synthesis and check what other products can be obtained. Friends, according to me, whenever we are doing the sulfur drugs, and especially the content is focused on the synthesis, we should be able to synthesize those molecules using traditional or other methods that are available for synthesis. The reactions that I am discussing as of now are taken from a medicinal chemistry book written by Asutosh Kar. So let us move with the third reaction, and this third reaction is sulfamerazine. So whenever I say sulfamerazine, how is that obtained? So first of all, let us write the final product or the structure of sulfamerazine so that we can just get an idea that at the end of all, we are supposed to obtain this product, that is sulfamerazine. Remember very well that when we say sulfamerazine, we are interested in getting a cyclized derivative of pyrimidine, and it is something like this. So this is sulfamerazine. While discussing sulfamerazine as referred over here, we have to be very clear that it is cleaved from this particular point, or sometimes this NH2 comes with the pyrimidine ring, and if the NH2 comes with the pyrimidine ring, then we have to cleave from this point. So this is now not a new product for us, and I will be not wasting yours and my time on preparing this product. We very well know that SO2Cl and NH2 through a long method of only para hitting and not ortho hitting, we can get this product. So let us assume that we are getting this product. We will be just focusing on preparing this product. Once we are able to prepare this product, we are on the way. So to prepare this product, which is nothing else but 2-amino 4-methyl pyrimidine. Remember, it is 2-amino 4-methyl pyrimidine. 2-amino 4-methyl pyrimidine. So if we are discussing 2-amino 4-methyl pyrimidine, let us first synthesize that. 2-amino 4-methyl pyrimidine is synthesized using acetone and ethyl formate. Ethyl formate is nothing but a structure of an ester. You can check very well that this is ethyl and this will be formate. When it reacts with acetone in presence of sodium ethoxide, that is C2H5ONA, what happens is very much important. At this particular point, it will be converted into sodium formyl acetone. And now the question is, how does it convert? So remember very well, CH3, CO, CH was this much part. We will just continue with the other part in a very short span. But first of all, remember this much part. You have CHONA. Now, the valencies that are not complete are to be completed. So, over here there has to be a CH2, and how it is structurally possible I'll discuss. CH3, CO, CH2, CH, and over here it will be ONA. You can see the valency is properly over here. If you can find that the valencies are not in a complete form, then there has to be an issue, but the valencies are complete. So it is CHONA. Now this product has to undergo a cyclization using guanidine. So how does it work? This product undergoes a reaction with guanidine. Remember, this is guanidine. So when you have 1 and 2 product where it is known as sodium ethyl formate, or rather sorry, it is sodium formyl acetone. So this is sodium formyl acetone reacting with guanidine, you will directly get the desired cyclized product in a single step, where you will have NH2 group over here and a CH3 group over here. So it is 2-amino 4-methyl pyrimidine. And now let us just combine these two products, that is one product 2-amino 4-methyl pyrimidine and benzene having NH2 group and SO2Cl group, that is 4-amino benzene sulfonyl chloride. This is 4-amino benzene sulfonyl chloride and that is 2-amino 4-methyl pyrimidine. When these two are combined, the final product that is obtained can be mentioned over here itself, NH2 SO2 NH, ring over here, nitrogen, nitrogen and CH3. So this is how, friends, we are getting our final product. And the structure that is behind me is not any new structure, but it is the cyclized structure that we were interested in getting, which is mentioned over here. This structure was just now prompting on my backside, that is here. So this is how we are completing the third important drug molecule, that is sulfamerazine, where the involvement of a heterocyclic pyrimidine ring is found. Now, if we check, we are done with three important reactions, that is sulfur thiazole, sulfamerazine and sulfonylamide. Let us move with the fourth one, that is sulfaline. Remember very well, sulfaline is again involving a ring, but this time the ring is a little different. If this ring was considered as pyrimidine, remember very well, friends, this ring will be considered as pyrazine. Do not make a mistake ever. This will be pyrazine. This will be pyrimidine. If we are using pyrimidine, then it will be sulfamerazine. If we are using pyrazine, we are preparing sulfaline. So this is the difference. So over here, what product we are obtaining or what product we are trying to obtain at the end of the reaction is very important. So it is again that popular reagent that now we very well know, and it is connected to a heterocyclic ring sulfapyrazine, and you have a methoxy group possibility over here. So this is the structure of sulfaline, sometimes known as sulfametopyrazine. So let us prepare this structure. Over here we have a very single step reaction. Even the synthesis of the pyrimidine replaced by pyrazine content is not important to us. We will be direct undergoing a condensation reaction, and when we undergo a condensation reaction, it is SO2Cl and NH2 undergoing this synthesis. What we would find is you have a Cl over here and H over here. It is replaced as HCl, and that will help you end up writing SO2 NH and our final product. So friends, this is how you get a new product, that is sulfaline. So we are done with four different synthetic reactions when coming to sulfur drugs. Now we are interested in moving with the fifth one, where you have another such molecule. But as of now, as we have done the four synthetic reaction, we will be moving for the fifth one, that is sulfur furazole. Now important is what is to be done when you have sulfur furazole. Sorry. See, whenever you first of all say sulfur furazole, be very clear that it is NH2 benzening SO2NH, and it is directly related to a heterocyclic ring where you have one nitrogen and one oxygen. Fura represent oxygen, Aza represents nitrogen, and all represents a total of 5-member ring. So it is something like this, and you have two methyl groups over here. So over here we are interested in this molecule and this molecule. Now if we plan cautiously and look into it in a little different way, this is already with us. This reaction I would be not discussing from Asutosh Care. I will be taking a different reference. So this will be my step 1 that I have earlier taught to you, and this will be my step 2. But the question is, let us try and synthesize this molecule. Let us try and synthesize this molecule. So among the different n number of methods available for the synthesis of this molecule, we will select one method which already I have prepared as a presentation for you all, and I'll be adding that product over here so that it becomes easy for all of us to understand that synthesis. So just a minute, we'll be adding that through a presentation so that you can just get an idea on what we are discussing. So until and unless we reach to that point where we can easily discuss that thing, I'll be helping you write few heterocyclic rings over here. So friends, remember very well, whenever we are asked to write thiazole, furazole, pyrimidine, and pyrazine. Thiazole means one sulfur and one nitrogen. Furazole means one oxygen and one nitrogen. Pyrimidine means two nitrogen, and pyrazine also means two nitrogen. So these are the four basic heterocyclic rings that we are taking into consideration while learning this particular section of the chapter. So now, as we were discussing sulfafurazole, we wanted furazole to be involved somewhere. So let us synthesize furazole first and then move ahead, because once we synthesize furazole, then and then only we can move ahead with our synthesis. So as discussed, this particular product is known to us. We do not require any repetition of the method, but Sure, we required a repetition of method for synthesizing this particular reagent. So what is that method of synthesizing is we have to start using hydroxylamine, that is NH2OH, and this hydroxylamine reacts with other important reagent, that is CH3CO CH sorry CH3CN. So first of all, let us make the IUPAC name for it. So it will be 2-methyl 3-oxo butane 1 butane 1 nitrile. So be very clear. This is NH2OH and this reaction, so it is hydroxylamine plus 2-methyl 3-oxobutane 1 nitrile. When these two products undergo a cyclization reaction, what happens over here is you get a cyclized product where you have oxygen over here, nitrogen over here, two double bonds, and NH2 and 2-methyl group. Be very clear, friends, that 1 CH3 and 2 CH3, these are those 2 CH3, 1 carbon and 2 carbon, these are those carbon. This carbon for us is key important, very important, and it has a nitrogen with it. So we have to be very clear what we are mentioning, or rather what we are writing. Now moving forward in the same steps what we are taking, after this cyclization we can move further with the second step, where this particular reaction will undergo the final step of synthesis. When it undergoes the final step of synthesis, Cl from here and H from here is removed. You will end up with this reaction. This is how you come to a conclusion, that is sulfafurazole. So it is sulfafurazole. So be very clear. If you have any queries up to this point, you can approach me. We will just have a look what all we have done up to now, so that we can just get an idea of what we are doing or what we were trying to do. So if we just go through the revision section, we will just get an idea of what we are doing or what we are on the verge of discussing. We have discussed sulfonylamide. We have also discussed few other reactions. So we started with the first one, that is sulfonylamide. We move ahead with the other reactions that involved the discussion of sulfafurazole, sulfaline, sulfur thiazole, sulfamerazine, etc. So friends, if you have any query over here, you can let me know. We will add two more things before we move further. Number one is, according to your syllabus, you have sulfonylamide. We have done it. Sulfafurazole. We have done sulfur thiazole, sulfamerazine, and sulfaline. There are two more drugs available over here. One is sulfaguanidine and second one is trimethoprim. I give you a task that you find out those two syntheses. If you have any doubt in those two syntheses, then just let me know. Apart from this, from your exam question papers or somewhere else, if you try to get other related questions of sulfur drugs or sulfonamide derivative drugs, kindly contact me. I will be happy to help you. You can just contact me on this number by a call directly. No messages, no WhatsApp, just a call. That, sir, we have so and so doubt in sulfur drugs. You can just please solve our query. Or if you want me to add something new in sulfur drugs in the form of a new video, I will be happy to do that. Thank you. Best wishes.